Hi, hello. My name is Chandra Setiawan. I am the author of paper entitled Design and Analysis of the Performance of Voice Switching Control System Prototypes for Air Traffic Control. Air Traffic Controller, or ATC, which functions as a regulator of flight traffic, uses voice communication as the main tool in carrying out its duties. The role of the air traffic controller is very important in guiding pilots when running an airplane in the air. In carrying out its function, ATC uses voice communication as the main tool in controlling flight traffic. In ATC, one of the components is providing communication and voice recording facilities for all controller working positions such as tower controller, approach controller, and area controller is the voice switching control system. The dominant VSCS technology currently uses analog-based circuit switching technology and time division multiplexing technology. Along with the development of computer-based systems and information technology with packet switching technology that uses the TCP/IP protocol, VSCS system with complex and expensive CS technology can be replaced with more modern and inexpensive systems based on voice over IP. This paper discusses research related to the design and performance measurement of the IP-based VSCS prototype using voice technology. The purpose of this research is development of voice switching control system, which refers to the standards of the International Civil Aviation Organization or ICAO and the European Organization for Civil Aviation Equipment or EUROCAE. The IP-based VSCS prototype that is designed to be easy to implement and integrate with other components of communication, navigation, and surveillance. In addition, the VSCS prototype is designed for the needs of small and medium airports in Indonesia. There are two main questions related to this research. Does the radio signal power level performance comply with the ICAO standards? Does the performance of packet loss, jitter, delay, and throughput comply with the requirements of the ICAO standard? This research took several procedures, including identifying research problem, continuing with a research subject, and collecting related theories. To strengthen this research, interviews were conducted with Airnav Indonesia at Hussein Sastranegara Airport in Bandung regarding the procedure for using voice communication in the process of navigating aircraft entering the airspace of an airport. The next step is designing a VSCS prototype, which is then realized by implementing the design results. To determine the performance of the VSCS equipment, tests and measurements were carried out. The data obtained From the measurement results are then analyzed whether this prototype can meet the standards set by ICAO. Performance parameters in VoIP communication consist of delay, jitter, and packet loss. The topology used in this prototype is a star topology with a local area network scope. The build topology aims to accommodate the communication needs of the VSCS prototype. The hardware used in this prototype are 19-inch touchscreen LCD monitor with function as a monitor display, mini PC that functions as a voice server, web server, and database server, mini switch which functions as an intermediary device on the LAN network, laptop to run softphone on controller working position, and client. Two-way radio communication is used as a radio communication on the prototype at a frequency of 136 MHz. ROIP gateway which converts analog signal from radio communication to VoIP communication over IP network. VSTN VoIP gateway converting analog telephone communication to packet data and forwarding it to the IP network. Via VSTN gateway enables analog telephone interworking with VoIP communication. The software used in this prototype is Linux Ubuntu Desktop with function as the operating system. For SIP server, use Asterisk. PXP script is used to build a controller working position application, and MariaDB is used as a database. And for VoIP client, use Linphone Softphone. All equipment is packaged in one portable box, enabling mobility operation of VSCS equipment. Measurements are made by sampling several data at different distances and using the same reference point for all radio signal reception location. The collection of location data uses 4 different locations by avoiding obstacles as much as possible in order to obtain line of sight condition. By taking different locations, it is expected that the entire radio signal propagation area in general can be covered in the measurements. On the display, we can see that the signal power level decreases with increasing distance. By using logarithmic in Microsoft Excel, extrapolated for longer distance and at a distance of 3,600 meters, signal power level has a value of minus 130.9 dBm or minus 163.9 dBw, which still meets ICAO standard requirement, namely VBN SG1-WP4 document. At this point, the minimum signal power level that the antenna should receive at an elevation angle of 5 degrees or more is minus 164 dBw or minus 134 dBm. The data was collected 5 times. Each measurement was carried out for 20 seconds. The results obtained in the measurements so that the average value is delay is below 20 milliseconds, jitter is below 9 milliseconds, packet loss is 0%, and throughput has a fluctuating value. The fluctuation of the throughput is very dependent on the intensity of the sound and noise that enter at the time of measurement. The total average value of the three-wave communication results in a value of 19.86% of the ICAO delay tolerance. From the experimental results, it can be seen that average jitter is at a value of 8.4 milliseconds with a percentage of 16.79% of the maximum jitter tolerance value. In this prototype, the packet loss is at 0%. The G711 codec shows good performance and is solid against packet loss. The variation in the value of throughput in the measurement is strongly influenced by the intensity of sound and noise that enters the VoIP communication network. In conclusions, from the performance measurements results, the ability of the VSCS prototype as a solution for ATC is able to meet the delay and jitter requirements as recommended by ICAO. For end-to-end delay requirements, the result is 19.86 milliseconds, and it meets the ICAO recommendation standards 100 until 150 milliseconds. The contribution of delay mainly comes from process delay, while propagation delay is neglected because it is very small. The propagation delay for coaxial cable and radio relay system is 4 microseconds per kilometer. The jitter on the VSCS prototype has a value of 8.4 milliseconds and is below the maximum tolerance limit of 50 milliseconds for streaming communication. For packet loss requirements, this VSCS prototype has a value of 0% and is able to provide toll quality for digital voice communication. The throughput on the VSCS prototype fluctuates. This depends on the amount of sound intensity and noise that enters the VoIP network. Thank you very much for your attention. Best wishes and see you soon.